Good afternoon. Today we are going to take some experiment in the virtual lab chemistry, online lab. In the beginning, I would like to introduce myself. My name is Mohammad Elayan. I'm a chemistry teacher and I hold a master's degree in chemistry from University of Jordan. And my experience in teaching international syllabus like IG, AS, A2, and IB. So today I will choose one of the important experiment in our lab. It's called concentration. As we know, when you prepare any solution, so we need two substances. One of them is called solute, and another one is called solvent. Then after that, sometimes the concentration, maybe it's high or low. But this, it's called qualitative expression, high or low. Now we need to go to use different and another technique. It's called quantitative technique by determining what? By determining the amount, specific amount of the concentration. It's called concentration. Again, concentration is the ratio between amount of the solute and the amount of the solvent. Now we can take the most information and more information about the concentration of the solution is the amount of the solute, maybe in the grams or moles, dissolved in 1 decimeter cube of the solution. So we have volume and we have moles. As we know, we can choose this equation to finding the concentration. Concentration equal amount of the solute by moles, volume of the solution, decimeter cube. So solution, we need solvent and solute. Sometimes we can use liter. So 1 decimeter cube or liter is the same. Converting unit, decimeter cube is the same liter. And both of them, it's equal 1000 mil. If we need convert the unit. Done. Now, we have another expression, another chance to concentration. We can say molarity. So molarity, M capital, the symbol of molarity, M capital, or concentration is the same, and both of them, it's correct. So molarity or concentration is the same unit. And again, molarity in the expression of mole decimeter cube of the solute. Again, we can choose the concentration. Now we need making a solutions. So I gave you like exercise, then we are going to use the virtual lab. How many moles? So we can here use moles. How many moles of NaCl would you need to prepare 200 ml? Look here, volume ml of a 5 molarity of solution. Depend of the equation, concentration equal number of mole divide volume. So we need number of mole, concentration times volume. We have concentration, molarity, 5 mole per liter again. And here we can use, again, we can use decimeter cube, done 0.2 decimeter cube. So we converted milliliter to decimeter cube by divide 1000. So it's equal 0.2 decimeter cube. So mole here, 1 mole. Now we need 1 mole of NaCl. Sometimes how we can get 1 mole? You should convert the mole to grams. By what? By using the equation grams equal or mass equal number of mole times molar mass of NaCl. So number of moles, it's 1 times the molar mass of NaCl, Na23, 35.5, it's 58.5. So 58.5 equal now the mass, we need 58.5 grams of NaCl. To get what? To get 5 molarity of the solution, to get 5 mole per liter decimeter cube. So here, in this experiment, we need balance, and we need aerodynamic flask and graduate cylinder. Here, graduate cylinder to find what? To find the volume again of the solution. To get the correct volume of the solution. Again, our volume of solution here, it's 0. decimeter cube. It's equal to 100 mil. So here we get the volume and put 200 mil in the aerodynamic flask. After that, put 58.5 gram of NaCl, then dissolving, you will get the solution of 5 molarity solution. By using the virtual lab, look here in this virtual lab online, we have here amount by moles, and here volume, solute, and solution. And we have here diagram. It shows the concentration. Done. So now we have different substance. I will use here like I can use string makes, yes, string. Yes, it's, for example, we have here cobalt nitrate, cobalt chloride, potassium dichromate, cold chlorate, potassium chromate, nickel chloride, copper, potassium, etc. Now I will put 1 mole, look here, it's 1 mole solution, and the volume 0.2, look here, liters, again, the same decimeter cube. So we get what? 5 molarity. That means our concentration or molarity, it's correct. So we can choose another substance to find the concentration. So this experiment, it gave us technique in the virtual lab to determine the concentration by 2 variables. Amount of the solute, it's by moles, and volume of solution by liters. Then you will get the concentration, the molarity of solution.